So, for the start of today's lesson, here is our problem of the day. Take a look at this equation and tell me, why the heck does it work? Take a few minutes and work through it. Pause this video, and then I'll show you how it works. So now, does it work? Yes. Oh boy. If there was another example, you could have done, say, let's say 6 over 31 divided by 12 over 62. And this problem ends up working out exactly the same. That is another example. Now, why does it work? Let's go through that right now. Now, all we're going to do is we're going to take our problem and we're going to basically change our division into fractions. In doing so, we have this weird looking massive fraction on top, 5 over 1 and 12 over 3 on the bottom. So in order to get rid of the bottom numerator, right, we're going to have to essentially multiply by 1. Now, you'll know whatever you do to the top of our expression, you have to do to the bottom of our expression. Now let's do that again. And this time, we're going to use blue. Let's look at the bottom. The bottom expression has a 3 on its denominator. So what we're going to do is we're going to essentially multiply it by 3. And whatever you do to the bottom of a fraction, you have to do to the top of the fraction. And so now what we're going to do is we're going to cancel stuff. So if you take a look at this, we've got a 1 and a 1 canceling here. On the bottom of our expression, right here, we've got a 3 canceling with another 3. This 3 cancels with this 3. So now when we do our final answer, we end up with the following. So when we simplify our top, we're going to have 5 over 12, and then we multiply by, well, whatever's left over, which ends up just happening to be this 3 over a 1. And that's why we simply flip and multiply when we divide. Now, today we're taking a look at these different types of sets. So when we talk about the natural numbers, when we describe the symbol, if you ever see me or any mathematician write the symbol looks like this. Now, on our first day, we talked about the integers. So let's focus on this first. When we talk about integers, we're talking about the basically all the numbers from negative infinity all the way up to positive infinity, all whole numbers. Now, what we're going to do is we're going to write Z based on our notes from yesterday. Remember, Z stood for the German word for integer, right? We couldn't use I because I was used for some other set of numbers that we don't know about. You won't know about that till university, most likely. Now, when we talk about the non-negative whole numbers, you need to realize that this set here, the Zahlens, has this set inside it. So I'm going to say that when we talk about non-negative whole numbers, most mathematicians will use Z, but what they'll do is they'll add a little plus to the top of it to kind of say that these numbers are all the positive numbers going from 0 all the way up to infinity. Now, what you'll realize is that these integers that go from 0 up to infinity sometimes include a 0 and sometimes don't when we talk about non-negative whole numbers. It just depends on the field that you're working in, whether it be engineering, science, geography, whatever. Sometimes 0 isn't counted when you're talking about non-negative whole numbers. Now when we talk about rational numbers, we sometimes call them quotients and fractions. And the reason why we have Q is because we think of fractions as a quotient. Now the only other thing that we have on our sheet is something that's missing. So this one is called irrationals. Now on your sheet there is a fifth row, and what you're going to do is you're just going to fill that in, and I'll explain what this is. When you talk about irrationals, we're talking about all of the rationals, but think of it this way: all the numbers that exist out in the world, except what we're going to do is we're going to say we're taking the complement. We're taking those that are not able to be represented as fractions. So these are numbers. So these are numbers that are not able to be represented as fractions. And examples of those you've seen, but you never knew what they were as a number. Pi is an example, and in essence root 2 is an example, and others that are out there are. Just think of these as numbers that are never-ending, numbers that don't have any real repeating values as you go all the way to the left of the decimal. Now the reason why you're able to calculate rational numbers is because there are repeated parts, i.e., for example, if I had 1/3, you could write it as 0.3333333 repeating, and there is a way for you to actually convert 0.333 into a fraction. Now, the types of rational numbers and fractions for conversions. Now, let's take a look at it. -5/8 equals -5/8, which is the same as 5/8. Why is that? It's because of the division rule. Now, let's go over some sample fractions that you came up with. When we look at proper fractions, we've got the following. Now, when we talk about an improper fraction, we're talking about the numerator being bigger than the denominator. So here are the examples you came up with, which were excellent. Now, let's take a look at a mixed fraction. A mixed fraction is nothing more than a mixed number with a proper fraction. And you guys came up with these. So we have 4 6/7 and -3 1/3. So how do we convert between mixed and improper fractions? Well, I have a recipe for that, so I'll just show you what it is right away. It has something to do with these arrows. I need to know what operations these are, and you came up with this solution. We take 6, multiply by 9, and add 4. Now, basically what happens is the result of that operation that we come up with is what goes on the top, or other words known as the numerator of our fraction. So let's do that. Now, following bedness on the top of the fraction, you end up with 58/1. Now, when converting from improper fraction to mixed, right? A lot of times you guys just sit there and you say, okay, how many times does the number 7 go into 61? So you sit there and you say, okay, so 8 times 7 is 56, so that means we're going to have this. We have 8 wholes. So now, in order to find our numerator, we have to take 56 and 61 and subtract them. 61 minus, 56. And we end up with the number 5 here. Another way to quickly do our calculations is to do long division. So we took 61 and divide by the quotient 7. So by doing so, we're just doing long division. So we just have to find out how many times. So 7 times, well, 8 is 56. 56 subtracted from 61 gives us 5. Now, this part here represents the numerator on our fraction. This part here represents the whole number of our fraction, of our mixed number. And moving on. Let's apply some rules. So last day we took a look at what would happen when we had a positive and a minus. What I want you to imagine is that if we're looking at a fraction with a minus that is attached to it, I want you to imagine that there is an imaginary bracket or brace that surrounds it. And based on that, we can use the rules that we did before. So in this case, a plus and a minus here become, so we get 2 over 3 minus 1 over 6. Now, we need to find the lowest common multiple. In this case, the lowest common multiple is 6. So we're going to have to take a look at this part here, and we're going to have to change it into 6. So we're going to multiply top and bottom by 2. So now we end up with 4 over 6 minus 1 over 6, which is 3 over 6. And then we're going to cancel the top and bottom. So 3 into 3 gives 1. 6 divided by 3 is 2. So our final answer is 1/2. Let's follow the rule that we just did before when we were converting mixed fractions. So anytime you have mixed fractions, the key idea is to change the mixed fractions into improper and then work with it. So 2 1/7 when we apply the rules from previous note, this is what we got. So we end up with 15 over 7 minus 3 over 4. So now the lowest common multiple is going to be 24. So we must multiply this by 4 over 4 and this by 7 over 7. And we get this result. Now we take away our numerator. 16 minus 21 is 39 over 28. And as usual, we'll try to make sure that our boxes are selected. Now do the last problem, and I'll show you what my final solution is. Pause here. So on that second last line, we divided both the top and bottom by 20 to get -1/2 as our final answer. So just as a final reminder, it's really important you take your time with these things. Remember that we're going to do a check-in in the next day or two. And now the big rules are as follows. So the big idea, when adding and subtracting fractions, you need to convert to mixed fractions first, and then ensure both fractions have the same denominator, and then only then fractions can be added or subtracted. And then we must simplify. So now let's go wade into dividing fractions. Alright, so basically we know that when we have any fractions, we have to make sure that everything is turned into improper fractions first. So we look at this problem here, everything is in improper or regular fraction form, so it's perfect. So now what we're going to do is we're just going to apply the rules. We're going to flip and reverse. Have that. Negative 5 over 9 times 11 over 10. So now we're going to do some cross cancellation. So you'll notice that negative 5 and 10 can both be divided by 5. So negative 5 becomes negative 1, and 10 divided by 5 gives us 2. So now let's pull all this information together since there's nothing else to simplify. So we're going to end up with negative 11 over 18 as our final answer. Now for the next problem, what I want you to do, in order to do this problem, you need to convert these fractions into improper fractions. Do so, and you should get the following. Now what we're going to do is we're going to flip and reverse the second part to get. Now we look for opportunities to cross cancel. In this case, 28 and 6 can both be divided by 2, so 28 becomes 14 and 6 becomes 3. So 14 times 5 gives us, well, 70 over 27, and we're done. Do the last problem on your own and we'll take a look at our final answer. When you flip and reverse the last portion of our problem, you end up with times negative 11 over 24. There's no simplification, so, well, 11 times negative 11 is negative 121, and 12 times negative 24 is negative 288, and a negative divided by a negative becomes positive, so we end up with positive 121 over 288 as our final answer. Now what I'd like you to do is I'd like you to take a look at the rules for dividing fractions. The big idea is, overall, if you think about it, division is no more than multiplication. So what we got to do is we're just going to have to take those mixed fractions that we have, multiply together, and try to get the lowest terms as possible. That's it. Just copy this down, you're good to go. Now, I tend to express my stuff in lowest terms as I go along, and that's why I have this second part starred. Copy one of these two. Either one of these ideas is perfect for you. So what we did here was, well, I put our division because our division incorporated our multiplication rules. So what I want you to do now is I want you to follow the rules that we just did to find these problems, and I'll put the solutions up in a minute. Alright, pause the video and then watch. So here we go. So for this first one, I'll notice that I have negative 2/3. What I'll always do by default is I'll always put the minus 2 over 3. So I always put my minus on the top of my fraction and then I start simplifying. So now negative 2 divides out with negative 6 and you end up with, well, you end up with negative 1 on the top and 3 on the bottom, because you divide the top and bottom of those cross cancelled problems, and you end up with negative 1 times negative 1, which is 1 over 9. So now let's do the same for the other. So the next problem here, pause and see what you get. See if you get the same as me. So the first thing you have to do is you need to convert your mixed fractions into improper and then multiply across. You'll notice that the top and bottom both have 7s, so we'll cancel those out to be 1 and 1. Final answer is going to be 15 over 4. Last problem doesn't have any simplification to do. There's nothing that can cross cancel. So basically the top part is, well, 19 times 4 is 76 divided by 15 times 3, There's a negative, so it's negative 45. And then we end up with, well, overall it's just negative 76 over 45. And we're done. Your homework can be found on the website. And it's found. Start by doing the ramping it up problem set and check to make sure that you understand what's going on. And then there's the homework that's at the end of the lesson. I will put the solutions up. Pause the video and I'll put the solutions up and you'll see if you got the right answer. This next problem is a little tricky. Basically what you need to do is you remember that you have to convert your mixed fractions into improper. And you should have something that looks like this. You'll notice the numbers in red. The lowest common multiple was 18. That's why we did that. And now on to the final problem before our assignment for the day. Alright, so I'm going to go in depth into this problem and give you commentary for it because some of you guys had some issues during class to do this problem. So the first part is we need to look at the top half of this fraction and then we have to look at the bottom half of the fraction. Each will have different things done at different times. So I'm going to focus on the top half of this fraction and then I'm going to look at the bottom half very quickly. So now we're going to do that for every line. So the first part we have to do is we have to change the 1 3/4 into, well, 7 over 4 by changing it into an improper fraction and then change that to minus 5 over 8. So now we're done for the top part of this first rewrite of the fraction. So now let's look at the bottom. So on the bottom you'll notice we have a complex here. A complex, a bracket of addition that needs to be done. Let's do that. So that's right here. Now in order to ensure that all this information is going to come together, we're going to make sure that we have the same lowest common multiple. So this is times 3 and then we're going to times it by 3 here because the lowest common multiple is 6. So this one is going to be times by 2 and this one is going to be times by 2. And so now our new bracket underneath is going to have this 3/6 plus 2/6 and we're going to times that by 1/5. So now let's go and rewrite the top half of our fraction. So the top half of our new fraction has a lowest common multiple of, well, 4 and 8. We'll just multiply this one by 2 and 2. So the lowest common multiple is 2. So you're going to get 14 over 8 minus 5 over 8. So I'm just going to stop there for that, and I'm going to look at the bottom of the next fraction. So if I look at the denominator of our fraction, we're going to have, well, 3/6 plus 2/6 is just going to be 5/6. I'm going to leave that in a bracket, and then I'm going to remind myself that I have to do some sort of multiplication. So now we have 5/6 times 1/5 on the bottom. Now let's move on to the next line. Okay, so now we have 14 minus 5/8, which is going to be 9/8 on the top. And then we're going to divide that by, well, there's a cross simplification here. We have a 1 and a 1 for 5, and so that ends up being on the bottom 1 over 6. So for me, I tend to take a look at these two fractions and I rewrite them like this. Well, 9 over 8 divided by 1 over 6. And you'll notice that I put my work in brackets because if you think about it, like I told you before, if I was dealing with a fraction, I would look at this single problem on the top fraction and the bottom fraction as though they were in brackets. So when I rewrite it as a division sign, it incorporates the minus signs that might be on those bottom fractions and top fractions. So now we have 9/8 divided by 1/6. So let's continue. So now you have 9/8, and then we're going to times this by, well, 6/1 because we had to flip the 1/6. So now let's cancel. Those two cancel. Both of them can be divided by 2, so this is going to be a 3 and this is going to be a 4. When we simplify and multiply everything together, we have just ensured everything is in lowest terms, so this is going to be 27/4 as your final answer, because 4 times 1 is 4. Please disregard that red mark you see beside the 4. Now, please go and do your homework.